So I'm getting ready to go into surgery. Not surgery for me, and I'm not doing surgery on somebody else, but I am going to do some surgery on a piece of electronic equipment. So what I have here is electronics repair video, and hopefully I can figure this out and fix it. And I'm pretty lucky usually on doing this kind of stuff. So I did study electronics engineering, and even though it was just a little home study thing that I took for 2 years, I did get college credit for it. So it was equivalent to getting an AA in electronics. So I did that because I was really into music. I studied music, and I also studied recording engineering. So I just wanted to be well versed in a recording studio. So this kind of all ties in with that. It's not boat electronics so much, but it is an important thing to have on a boat is music. So what it is it's this recording monitor I have here. It's a KRK, and I've had it for quite a long time and hardly ever used it. I have 2 of them, and I had them stored. I had plastic garbage bags over them to keep them dry, and evidently moisture got into this one, so here it is. And so it's a near range monitor, and it's bass reflex, so it has a hole here. It lets the air from the back of the speaker out, which increases the low end, so it gives it more bass. And so the problem is I took them out of storage, and I set them up and turned them on, and they both of them made noise when I first turned them on, which I don't recall them ever doing. But after a couple seconds, the noise totally went away, and they were great. And so that worked for a couple of days, and now this one just is now constantly noisy. So I'm going to turn it on, and you should be able to hear it. So it's that buzzing sound. So I'm going to go ahead and turn it off. These speakers have built-in power amps in them. So they have an audio amplifier built into them. And so that's really cool. And they're really cool little units. They have a high frequency adjust on the back. So you can adjust the level of the high frequency of the speaker. So that's coming out of the tweeter. And it ranges between minus 2 dB and plus 1 dB. So you get minus 2, it's stepped. So there's 4 adjustments here. So it's minus 2 dB or minus 1 dB or 0 dB or plus 1 dB. And then it also has a volume adjust on the back. This is rotary, so you can adjust it, and it goes from minus 30 dB up to plus 6 dB. So you can adjust the volume level of the monitor itself. And what's also cool about these is that you can use 110 volt power supply. So that's like the United States, and then like Europe and Great Britain, they run on 220. So you can connect this to also 220, and there's a switch to switch in between. So this is really cool. And then one more really cool feature is it has 3 inputs. And so it has an unbalanced RCA input, and it has a balanced TRS input that's balanced. And it also has a balanced XLR input, which is like a microphone cable input. So it gives you a lot of options. So what I'm going to have to do now is I'm going to go ahead and take this apart. And I've never taken one of these apart before. And so there's a bunch of screws on the back, and hopefully I'll figure out which ones I need to remove. I think I got it figured out. I think it's the bigger screws that hold this back plate in, and hopefully I'll be able to slide this out and hopefully be able to get to the amplifier, because I'm sure it's either the amplifier or the power supply. My guess, with experience of fixing stuff like this, is that it has a bad connection on, probably it's a bad connection on a electrolytic capacitor. And I fixed a lot of equipment. People would give me music equipment, electronic music equipment, and say, I'm just going to throw it away. Do you want it? You think you can fix it? And a lot of times I could fix it. So, and usually that's what it is. So I'm going to go ahead and take the back off here now and see what I can see. Be warned, anything with capacitors in it can kill you, depending on the size of the capacitor. Old TV sets, before flat screen TVs were invented, they have large capacitors in them, and even though they're not plugged in to the wall, they're totally unplugged, you take it apart and get into it, and the capacitor happens to be charged, one of the capacitors, and it zaps you, it can kill you. Same thing with like guitar amplifiers, any big power amplifiers, anything with big capacitors that use quite a bit of power can be deadly. Even pretty small capacitors have the ability to kill somebody. So you really need to know what you're doing to do this. I don't recommend anyone just trying this. And then you also need to know how to discharge the capacitor once you get into there. So whatever capacitors are in there, the bigger ones, need to be discharged before you go sticking your hands in and playing around. So let's see what I can do. And hopefully I can get this back panel off without too much problems. I don't know exactly what I'm going to find in here. There's a bunch of screws on the back, and I'm thinking that that's holding some components onto this backing plate here. So I'm just going to remove the outer bigger screws first, and then I think there's a couple. There's one big screw here in the center, and I'll probably have to remove that one to get this off. So we'll see what we get. And hopefully I can fix this, because these little monitors, these little close field monitors are really cool. And they sound pretty damn good. They got quite a bit of low end for such a small speaker. In recording studios back in like the late 70s and all through the 80s, there was these little monitors. They were a little smaller than this. They were called Ortones, and I had a set of those, and those things were just awesome. They're acoustic suspension speakers, so they're airtight, and they're super accurate, and they're actually pretty loud, and they could actually produce, some low end, not a lot. I mean, it didn't rattle your body, but they were super accurate, and so that's why a lot of recording studios had them. And you'd see them sitting up on the top of the mixing console where the meters are. And so some studios have far range, depending on the size of the control room. They could have far range monitors, and they can have midfield, actually, it's midfield monitors, and close field monitors sitting on the console. So you can, when you're mixing, you can compare the different monitors and the sounds that you're getting. I built a set of midfield monitors that I have, and they're awesome. I designed the cabinets myself. I put in JBL drivers. Each cabinet has two 8-inch JBL drivers, which aren't real big, and I ported them. I was originally going to make them acoustic suspension, but the drivers that I had were bass reflex. Okay, this one I'm not taking loose because it's not coming out. It's just spinning. And so I think I got all of them around the outside, and hopefully I can pull this out. I don't know. It's doesn't feel like it's going to move. I don't want to have to take all these screws out in the back because stuff will start falling off of the... Oh, there it goes. I got it. Okay, now it's where I got to be careful. And I can already see the some circuit boards in here and a heat sink for the amplifier. So I got to be real careful. I don't fry myself here. And so, oh, I hope these are, ooh, looks to me like I might be able to unplug these. Okay, that's good. I can get in here enough to see what I need to see here. These do have plugs, it looks like. Right now I see some capacitors. Okay, so I have a big transformer here, and I have two capacitors right here on the outer edge of this board. And so these are the ones that I'm worried about here. So I'm going to have to discharge them now. As you noticed, I did have this plugged in and I turned it on so you could hear the buzzing sound. So that means these capacitors are charged. So what you do is you take a screwdriver, make sure you're not touching the metal, and you have to jump the capacitors. So you short them out. You short the two capacitors, electrolytic capacitors. Let me see if I can turn this around so you can see them. But there's two of them back here. And actually there's more. There's some other smaller ones, but the two bigger ones are right here. So I don't know if you can see them. Let's see if I can get more light on here. But they're right here. Let's see what I can do. This, trying to get some light here. There we go. So here's two of the capacitors here. So more than likely when there's a problem with capacitors, it tends to be the bigger ones. So I'm going to go ahead and short these two out, and I can tell which way the leads are from this indicator here, and I can also see them on the circuit board. Now there's two other capacitors farther back that are smaller. They're about half the size of these. So I'm going to go ahead and these capacitors probably have something to do with the power supply. So usually what you have is an AC transformer here, and then it goes through what's called a bridge rectifier, and then they use capacitors to smooth out the AC and turn it into DC current. So I'm going to go ahead and short these out so I can discharge them, and hopefully they'll be safe. And so I'm just going to go ahead and touch and make sure I'm not touching any metal here. I do have my hand on this outer thing, but that should be okay. Matter of fact, it'd probably be a good idea not to touch that either, but I think it's okay. It's just ground. So I'm going to go ahead and see if I can pop these. Okay. Okay, I shorted that one out. And no sparks, so no big deal. They're not real big capacitors. They're actually not too dangerous. It's the big ones that are really dangerous. Okay. So that should be good. So those are the two leads, and I'm just bridging them together and making sure that they are shorted out. Yep. Okay, it should be safe now. Now, usually what happens with capacitors, because they hold a charge, they're like a battery. And you have dissimilar metals. So you have solder, which is, I have some solder right here. And it's usually a mixture of tin and lead. And so right there you got dissimilar metals. And then also this metal on the circuit board itself, and also the metal on the pins of the capacitor. They might slightly be different. So what happens a lot of times is you get galvanic corrosion, which happens when electrical current passes through metal. When you have dissimilar metals touching each other or close to each other, what happens is there's a list of nobility of metals that you can find on the internet. And the more noble the metal is, the less it corrodes. And it'll make, matter of fact, if you take two different types of metal and stick them in salt water close to each other, not touching, but close to each other, the more noble metal will actually make the less noble metal deteriorate. And what's actually happening is there's a current going from, flowing from one metal to the other. And so what happens is that the least noble metal, the current flows from that into the other metal. And as it does that, it's actually taken atoms from that less noble metal out of that metal and putting it into the other metal. So it's transferring it. And that's what causes the corrosion. So like boats, props and prop shafts and rudder posts and stuff like that that are underwater especially in saltwater and ocean going boats, will have zincs, sacrificial zincs that are you put onto the prop shaft, onto the rudder post as well. And what happens is that is a low noble metal. The zinc is, it's one of the lowest on the scale, and it will deteriorate instead of the other metal deteriorating. So it'll save your prop, it'll save your prop shaft, it'll save your rudder post. So it's the same thing, even in an electronics. If there's moisture in the air, and then you also have, a capacitor that's charged and holds current like a battery. So there's there's a voltage potential there. So what I normally find is the capacitors will get galvanic corrosion where it's soldered to the board. Now I'm going to have to get my magnifying glass out and look. So what happens is you have a circuit board with the foil on it for the circuit, and then you have a hole drilled through the circuit board, and then the components have little wires that go through the circuit board and then solder onto the foil side of the circuit board. And so because it's dissimilar metals there, a lot of times you'll get galvanic corrosion. And what I'll notice is that where the pin is soldered to the circuit board, on the solder side of the board, there will be galvanic corrosion around that pin in the solder joint itself. And so what happens is you can see a little black ring around the pin in the solder. So I'm going to get out my magnifying glass and see if I can see that. I don't really think I'm seeing that, but I need to look closer. So what I'll probably do is I'll just go ahead and resolder them anyway. And another thing I can do, and I've done before, I push on the capacitor, push it into the circuit board. When there's galvanic corrosion, the wire lead coming out of the capacitor, well, because of the corrosion around the solder joint, when you push on it, the wire lead will stick out. It'll move on the solder side of the circuit board. You can see it moving, and you know it's not connected. And so what happens there is that it can cause noise or the unit to fail. So I'm going to press on these and see if I can see them move. I don't think they're going to move. They look real solid and they look welded or soldered well. I got my little can of butane here. I went to buy butane for the soldering iron, and I couldn't find a little can anywhere, and all I could get was this great big damn thing. Lifetime supply. Okay, so I gotta see which nozzle. It comes with a bunch of nozzle sizes, which is really cool. Okay, when you recharge these, you want to make sure that it's cooled off. You don't want to try to do this while it's blazing hot. Not a good idea. I think I need to put a nozzle on here because this is not going to work. No. So now I got to figure out what size nozzle it is. So I got 5 nozzles here. I got to figure out which one it is. Oh, that's better. Okay. Ooh. This is kind of dangerous. You definitely don't want to be around any flame Even static spark can ignite it. And yeah, it'd be not doing too good. Okay. Let's see what happens now. Gonna let this kind of dissipate here for a second. Oh, that's better. I can hear it now. Okay. It's working. And what I'm going to do is I'm just going to reheat these joints and then resolder them. Okay, it's plugged in. Now we're going to turn it on. Oh, nope, it's still buzzing. Nope, that didn't do it. Okay. So much for that. Let's see if I can see anything else. So I'm thinking it's a bad transformer. And so it looks like this might be a lost cause, unfortunately. I think I'm just going to kind of leave it apart right now and see if I can think of anything else to do to it. It's getting late tonight and I got to cook dinner. And so I'm just going to let it go at that. Unfortunately, it wasn't a victory. And usually I'm pretty lucky with this stuff. And but it sounds to me like it's the transformer that's humming. And so it's probably the transformer's bad. I can see where it's connected to the circuit board, so I could probably go ahead and get my voltmeter out and test the voltage and see what's going on with the voltage coming off the transformer. But it's getting too late tonight, so I'm going to have to just let this go for tonight. And so if I'm sure you didn't find this video too helpful, but at least if it was entertaining, please like and subscribe. Thank you.